Okay, good morning everyone. We will continue with lecture 4. If I remember well, we finish until slide 20. So I will just go to this slide. I already described what is dominant spectral component. That is the strongest reflection. Good morning. That is strongest reflection in our Doppler spectra, caused by end of the end tips of the blades. And we just finished on these slides yesterday, so I will continue and finish lecture 4. It is about next 20-25 slides, something like this, and we continue lecture 5. So there is example how Doppler spectrum is affected by signal from reflected from wind turbines. There is just example. I will describe original spectrum that should be visible in our radar. Unfortunately, due to PRF, our zone is in range plus minus 500 Hertz. So it is in this range. So we are outside this range. So what's happened? Of course, it is happened aliasing of signal. This is presentation of replica of this spectra, because you know this is original spectrum. This will be -1 replica, -2, -3, -4, and so on, and there will be original 1, 2, 3, 4, and so on, because spectrum is periodically repeated due to this aliasing. So what's happened? How will looks our signal? Imagine that our reflection has central frequency after sampling about 750 Hertz, but due to this aliasing, it is described by this formula, and it is sum of individual repetition periods, and they are of course infinity, because it is original, first zone, second, third, 4, 5, 6, 7, and so on, and it is for positive and also it is for negative. So due to this aliasing, due to this limitation of our range plus minus 500 Hertz, our reflection not will be visible in this frequency, but aliasing frequency will be right frequency. It is this 750 minus round f through divided PRF again, and if you will compute, it is my 250 Hertz. So what's happened? We won't mitigate this one, but unfortunately due to low PRF, and you can't choose it always, because what depends Doppler frequency, maximum Doppler frequency of this spectra on rotation speed, length of blade, and so on. So you can influence this thing, because it is depend also on speed of wind, rotation speed, and so on and so on. So this spectrum will be in minus 250 Hertz, and it caused us problem. Why? Due to this aliasing, of course, our mitigated algorithm, that is derived from UKF filtration, it is Kalman filter, try to estimate where will be in next step this maximum. So he will expect something like this, around this, but due to aliasing, it will be there. So of course, due to this aliasing, when aliasing occurs, our estimation algorithm, prediction algorithm fail. Of course, if will be only in one spectra or 2, 3 of them, 2, 3 prediction, it will be okay. The prediction algorithm can handle it. But if will be continuously for longer time, then this prediction fail, and what's happen? Mitigation algorithm will stop work. But you can handle with this, because it is, it is not your fault. It is not fault of mitigation algorithm. This works fine. but due to this aliasing, this sometimes could happen. But when happens, it not will be so often. Only when this Doppler frequency will be very high, and it is mean for really high speed of rotation with length blade or something. But could happen. Just you need be how to say, you need be careful about this. Okay, so now I will talk a little about high variability of wind turbine RCS. I already told you what is RCS. It is radar cross section, it is radar signature, and it is measure like object visibility strength of reflection. It is on meter square, and the definition formula is sigma is limitation r go to infinity 4p r square capital SS divided SE. And what is it? You can see why, sorry, where is my mouse there, that y is meter square, because this divided this has say units, so it will be of course meter square, and SS is scattered power density and SE in incident power density. And what this mean? You have some energy that go from your antenna beam to target, and it is this amount of energy that hit target. And what is SS? It is reflected energy. So it is basically like two energies, but of course you will hit target, but in some area. So reason is why it is in meter square and Vp r squared. So on what is dependency of RCS? Okay, there also I won't present, I found already from this source example of wind turbines reflection. It is in one time instance, so it is mean it is in one time. In second time will be completely different. If you change some angles, anything, rotation speed, it will change, of course, this diagram. And check, it looks pretty complicated, isn't it? It is hard to make decision. There is not any, how it is look like almost random. Why? Because every part of surface has another reflection angle, and the result is this. So I even can't describe more, it is just results. It will look something like this, and it, of course, and if you will change about 1 degree angle of blades, it will looks completely another shape, another. So this, you must say, you can't predict. It is not possible. This frequency, this measurement was made on frequency 3 GHz with horizontal polarization. It was wind turbine from company Enercon E70, and rotor diameter was 70 meter and tower height 65 meters. So relatively small wind turbines, but it is nice example how looks real RCS from wind turbine. If you don't know that is from wind turbine, and I told you that is from some UAV or from some plane, you can't recognize because everything looks similar. It is something like this. So you can see that reflection is very variable and vary in the units are in dB. So you can see that this is really big differences. And why in some angles is almost zero and in some angles is maximum. It is depends how it's reflected, how looks surface, how is rotated, which angle, because in some angles energy can reflect to space and you don't know it. And of course it is depends on movement and so on and so on. So it is not possible to predict. So dependency of wind turbine RCS is on rotation of the wind turbine nacelle. Of course it is how it's rotated. Blade hub, or it is orientation, generally orientation of wind turbines, rotation speed of the blades, and it is depends on wind. So generally you can't predict this also. and also depends on polarization and frequency of the signal transmitted to PRS. So it is carrier frequency, okay, we can change it, it is based on our radar parameters, and polarization, okay, it could be horizontal, vertical, or cross polarization, and it is mean you transfer one like polarization but receiving another polarization, so it is just cross polarization. It is this reason. Also depends very much on specific type of wind turbines, because shape of blade is in each turbine little similar, of course, but different, for sure, little different. And also it is depends, and I missed there, on material, because individual material, they have different reflections, so also on this. So it is so many variable, how you can see that is hard. What is typical RCS of wind turbine? It is very, how to say, very variable, and it is from 100, oh sorry, there is check word, up to 1000 meters square, in dB about 20 to 30 dBsm, and this value for sure mask almost any of your target. And if you will take care about small target, it will mask for 100%, because the reflection RCS of these targets will be on similar level or low level. So if you will look at the same direction where is this strong, you don't have any chance to saw this target. Another approach how get RCS is in FEM RCS simulation, but we don't include it. It is very hard and very hard. It is very computational intense, very, because of course we can simulate one shape blade. It is available, this shape of blades, in 3D CAD, so it is not problem to get it. But imagine, it is depend on frequency, it is wavelength. So I need take this model and make this model like 150 meters length. In 3D I know that is possible, it is not problem, it is just ratio. But then you need to compute reflection surface on this every small units to get RCS. How you could measure RCS generally? You know probably that is in anechoic chamber. So we have some experience also with measurement of RCS of UAV, because we have anechoic chamber 5 by 5 by 5 meters, something like this. So we can measure some smaller object, but for UAV it's not problem. I think that maximum what we already measure, it was UAV with wings, and it was about 1.5–2 meters, something like this, because for bigger objects you need to be in far zone, not in close zone. So of course for us it's not possible to measure this one. Why you can't measure directly RCS outside? Because it is influenced by environment, other signal that is in environment, and so on. So you will not get it. Okay, you will get measurement, but you don't. It is not mean that it is RCS, just RCS. It is RCS plus much more other reflection. Now we leave for few slides, formulas and all this, and we go, I hope, to little interesting thing. It is about analysis. This is example of scenario. Until now it was like purely theoretical, if I can say. We just thinking events. Modeling, simulation, calculation are but not enough. Imagine that I need make some measurement. Okay, I can look at map, Google map, our maps.com and so on, and check it. Okay, it is good place for measurement, I will go there, and so on and so on. But it is map. It is not exactly right. So you always need go to Street View or something like this and check it. Did I select proper measurement? Because imagine you will select some displays and now you figure out that there is wood and you can saw it. So good preparation of your scenario based on publicly available maps and or another types of software that I will later show you. It will help you save your time, that you will arrive to measurement place and figure out that is not good place. So for measurement, real wind turbine is also embedded in specific geography, so you can get information also about trees, about roads. Imagine that you plan like on opposite side of road, on like left side, that you want make measurement from this distance if you will continue, and now you figure out that there is main road and just driving cars. And what this mean? That is rotation of the wheel. It is small wind turbine, it is rotation, it is again will be RCS, and you don't get valid measurements. So site selection, it is very important, and honestly we spend a lot of hours before we go outside to take proper minimally 2-3 places where we can get measurement. Why more places than one? Because we don't know in exact day, exact hour how will be rotated wind turbine. It is also for you unknown, so it is better planned 2, 3, 4 measurement. And now you need to fulfill, of course, ambiguity range, blind zone range, and power range, power budget, and all these things. So you found good place, and then you figure out, oh, it is too far, I don't have enough power. Okay, and you search it again and again. So this planning looks like that is not important. It is very important because save your time. Save your time. Also, probably 2 or 3 times happened that we just arrive, we check one day before, okay, turbine's working, we driving 70 kilometers, and there was some maintenance and we just go back. So it is not so easy task. So please, if you will handle it with these things, plan carefully and from publicly available sources. Of course, everybody knows Google Map. They are good, but they don't have it measurement of distance and elevation profile. For this reason, I little force you. It is Czech site, mappy.com. It was Mappy CZ, but they changed it before a few months to be globally, and of course it is also in English, so don't worry, it is not only in Czech, but there is measurement distance, and when you just put 1 point, second point, it always will show you elevation profile. Of course, elevation profile, it is just approximation. There is no woods, there is no trees, there is no buildings, and so on. So need be careful about this. Also, measurement very strongly depends on windy season, daytime, and also on acquisition period. So there is an example from one of our measurement. Don't worry, I will have more example and you will try it. It is really crucial use map-based tools. It is not from Google Maps, but from our site, and you can see where is red one. It is mean where is possible like street view that you can rotate in and check it like classic street view. They call it panorama, I think, but it is the same things. So this is, I don't know if you see this triangle. It is the view where I watch it, and it is just copy and paste photograph. So you can see 2 wind turbines. Good visibility, there is some field, there is no tree, okay. We can go for measurement. And always plan like this. It is not so hard, okay, understand, take some time, but it is not so It is not so hard and really save your time. So, problem is that we plan few times some better place, because this is of course roads, small roads and so on, but then figure out that there is some tree, there is some, I don't know, pond with reflection, there is something what is not good for measurement. So for this reason you always need to check carefully, and this help you, for sure this help you. Because there you can have some obstacles, there can be even some new, how to say, buildings, barns, if you are in agriculture, anything. And this is problem. Also, always first check what is version of your map sources, because sometimes you can switch to newest one. Probably it is always newest one, first choice, but check it, because it will be 2-3 years old. Like on Google Maps, some area is older, some are newer, because they are updating, but not whole world, of course, regularly. Check it, because it is also just very important things. Oh, 3-4 years old, you cannot believe it. Especially if you will be close to some density area where is a lot of buildings, because they are growing very quickly, you know it, so this could be also problem. And other clutter, but I already mentioned, is unresolvable highway traffic, and this really costs you problem. This rotating wheel, it is perfect reflection. You can't recognize. Okay, imagine if you have rotating wheel on car, you have 2 of them, of course you can see it from side. It is like rotation of blades. In UAV or something like this, it is completely same RCS characteristic, or it will be micro Doppler, it will be completely same. So you can't recognize this one. It is similar, how to say, it is similar movement. Why I explain this highway traffic, because we already found very good, nice place for measurement, and we figured out that it was so high traffic that we can do it. So it is from own experience. Okay, there is some other example analysis. We always prepare scenario where we won't make measurement. When we decide where will be good place for measurement, like this one, position of, I call it radar, but of course it is our measurement chain, but it could be radar. This is individual small villages, this is main road, and this is city Litomyšl. It is about 40 kilometers far away from our city Pardubice. And you can see this is line of sight. There is position of wind turbines, and there is, if you could make, how to say, zoom, there is 1 and 2nd wind turbine. Later I will show you exactly in data. So I want to highlight that your measurement and everything is also related on quality of our geographic data, because map, this map, any map, it is not picture. It is list of geo objects, and it is important to inform. Of course, for us, Lukács picture where we won't go through navigation, I don't know, but it is not true. Any object, if you will zoom it, you will see individual buildings, and everything is object. And like like example, OpenStreetMaps allow you check which type of object, and sometimes give you information about, I will show you there in OpenStreetMap, that there will be information about which type of wind turbine, which hub size, who is developed this, where is exact location with 1 meter, and so on and so on. So save your time with map. You will spend 1-2 hours with map, and you will save a lot of hours with going there, gathering equipment, and so on. So be careful, map is not picture. even it looks like picture, it is not. There, where you can get good data source, I recommend free source OpenStreetMap. If of course you have some commercial like commercial maps, or I don't know, you are working in partial military, so if you have military map it will be much better, because there will be any object even with a lot of additional parameters about the height of building and so on and so on. It is always depends on details. But OpenStreetMaps, I like it because they show you a lot of information, and there is example from OpenStreetMap. If you will click information, where is it, what is it about this object, so I click to my wind turbine, of course, so you can see it is generator method, it's wind turbine 2 megawatts. It is wind turbine, of course it is like source of energy, it is different categories, and everything it is like subcategories of geo objects. So you can see it is not picture, it is really objects. And what is really nice on this, on OpenStreetMap, that you can make like filtering which object you are interested in, which not you are interested in. You can even download it from specific area, this object, and put to your some GIS system, map system, and this allow you working offline or with all object that you are interested only. So you want only wind turbine, okay, just download information about wind turbine. You want interested in buildings, okay, download buildings, and so on and so on. So it is really nice and powerful tool. I don't know if you have experience with this one, because everybody looks like, okay, it is map. It is not, it is true, but it is not only map. And it is really easy. You can see there is manufacturer, week of wind. It is model wind turbine, and if from model wind turbine, I can find data sheet, I can find anything. What is blade length, what is rotor, what is tower length, what is power, what is maximal speed of rotation, minimal, oh, okay, minimal will be static, so it will be 0, but you get my point. It is very useful, and you can just sit on your PC and you will get all this information without any reason go to displays before measurement. And something else, yes, there is also source of information. And now one important thing, I choose this one because there is a lot of information, but of course in a lot of sites there is no information, then you need to go there and check it. So it is not like 100% sure, but always check it, always check it. I check a lot of wind turbines in Tamil Nadu, where is this big area, and unfortunately there is no information about this wind turbine, so I don't know which type of wind turbine. I try use Street View close to this wind turbines where was available. Unfortunately, around this small street there is so many buildings that I don't found any like view to these wind turbines, or maybe some part of blade or something. So sometimes it's possible, sometimes it's not. It is depends, of course. But I didn't expect that, especially in Tamil Nadu, will be information about all of them, because I think it is thousands of them. But you can find it also maybe on internet somewhere else. But please use this. And now I will. You probably know OpenStreetMap. So I will open this one. I hope that connection works. Yes, works. Okay, so I will zoom you. So check. There is Pardubice, where is now university, and there is main road which go to Moravia. it is this part Litomyšl that I show you on map, and they call it wind turbine Janov because it is this smaller village, it is closest one. And if you can just go down, okay, sorry, there is, oh, you saw it, I don't saw it in this screen, so it is there. If you, of course, please, I will switch to English. It is always, my system is in Czech, of course, operation, so it show me in my system. You can check it, and if you will click this, you can see this exclamation. You can click read futures, and there is VTA. It is wind turbine, but in Czech you open and you can see all this information. If I will go there, it is in Czech, so it is Czech side, but you can make a Google translation, and now you have power, tower height, rotor, so the wall weight, total weight with blade 100, and so on and so on. So you can see I can find a lot of information on web. There is some additional information. Oh, it is what I already showed you, sorry. And one more software that will be very, very important for you is this one. It is QGIS software. It is visualization of any map layer that you can imagine. It includes thousand and thousand plugins for different viewing, for handling with maps, and each map, like you download map from from OpenStreetMap, then you will download layer about wind turbine, then you can with building and so on, and you can work with this like with layers only. And what is the best? It is free. It is community project for 25 years. It is size 1.2 giga, something like this. You can download it, and map sources you can put on. You can download CRTM data. You can download digital elevation profiles data. You can download information about building, wind turbines, what you want. OpenStreetMap, and everything will be like one layer. We are using this software often, but honestly I think that I will use this software from point of view the whole functionality maybe for 0.1%, because it is huge, so huge for many tasks that I just use for wind turbines and for these few things. So I will show you later some example how it looks like. So I recommend you this one, and it is free. It is perfect. It is also free. So I already talked about digital elevation model. So why is for me important? Visibility, line of sight. You can see. Of course, you can check it through this panorama or street view, but never can be sure that it's right. Or how to say, it is good source, but sometimes you need to compute directly line of sight. Sometimes you need to work even with reflection from environment. So I will later show you how you can get 3D elevation model. It is imported to MATLAB of any part of world. It is freely available. It is they call it CRTM data. It is space shuttle mission with SAR, radar. It is on board. Resolution is free, and it is approximately about 90 meters and 30 meters. And the whole world except Arctica, Antarctica, I think, except these two areas, it is with resolution 30 meters. And it is on tiles. It is like one tile, second tile. So you will download only area that you need. Import to MATLAB. I also share this tool It is available on MATLAB Central, and you just downloaded this tile, put it to MATLAB, and then you can make presentation. By the way, this one, it is position of my radar, and this is position of wind turbine, but it is not in good ratio. It is just for, how to say, for example, if you get my point, where is it? Because of course radar is not so high, it will be down, and this is too low. It is just picturing where is your position. You can make rotation, you can make computation, you can do anything. I know there is no information about woods, about any obstacles, but still really nice one. Because if you will picture this one from 2D, you will see something like this. Okay, perfect. Again, this is not in good ratio, it is just picturing. But this is digital elevation model, and it is perfect because you can see easily. Is there good visibility or not? Imagine I will be there. Okay, there is no visibility, or there will be some hill, and you have Himalaya, something like this. There is really like not flat. So it is good tool. It is good tool, and I recommend you. And it is even a little fun work with this. It is interesting. This tail, if you download, if your like area is through more tails, you need to manually connect it each other. Why manually? Because you need to tell this is first, second, third, fourth, five, and second layer, and so on. But it is not so bad. You will download it very easily, and then just connect together, and you can see this one. Again, during tutorial you play with this, and I will give you all this MATLAB file so you can play it. Only I have downloaded data about Czech Republic, the whole Czech Republic, because we are a small country, and I will show you also how you can download any part that you want. So, but we made analysis in Czech, so everything looking catches, but it is not important. It is just another type of data. So, and what is good thing, I can in QGIS, in this, where was? No. In QGIS, oh, there, in QGIS software, I can easily this digital elevation model put to QGIS, so you will see map like this one, you will see elevation profile, you will see wind turbines, and everything. You could like make more intensive, less intensive. What do you want to see? You can disable individual layer, enable individual layer. So what you want, you can just make visualization. So it is really powerful tool and free. I think that is really nice. There is one thing about it is German words. I don't speak German. I will try. Dunkelflaute, something like this, and it is special words. And it is it is German term for combining dark and calm. What is mean? When is no wind, it is referring to periods with low wind and low solar irradiance, and this is example of activity. There is how many megawatts in some area was like how to say made it from wind turbines. So you can see this is intensive, there probably no wind, intensive, and so on. And this area is almost close to zero. What does mean? Dark and no wind, completely no wind, really calm down weather. And what does mean? All wind turbines in this area will stop work. And why I take care about it? Because when they stop, they are not moving, and if they are not moving, no Doppler shift, and if no Doppler shift for me is static object, MTI filter is enough. So it is just interesting thing, and it is really you need to be careful if there is some prediction that this period will happen, don't go to measure because it will be just static object. So I want also show that this how to say, interferences of RTS, which depends on speed, is really strongly weather dependent, and this is just presentation of this. So measurement timing, you need to go with windy season, daytime, and you with some data acquisition period. And of course, in any country, in any area will be different, this one, so you need to plan carefully. There is one interesting paper that we found in during our research, and it is about exactly this Dunkelflaute period analysis in China. There is lot of graph and some statistic. So you can see when during January, February, March, April, there is number of days when was sun, when is dark, when is wind, where is no wind, and so on and so on. So also you you can check this different statistic if it's available maybe for India, for any country, because it will help you also with planning when go to measure. So it is this environmental layer is very important, because also it's connect your modeling and prediction with real work operational variability. Because imagine you can also make some adoption of your mitigation technique depends on this, because you know that with some statistic in this time is some kind of behavior. In other time, during nights, it is another behavior. But it is good for adoption of your mitigation algorithm. Of course, it is very, very detailed, I agree. You don't need to use it. But you can. And if you will use it, it is just next layer of your model, and it will be deeper and deeper and precisely and precise and better and better and better with better results. So, combining basic metadata with your model, it also could help. It is just next layer of information, and you know it is always, if you have more information, results are better, always. It is same like AD conversion. If I will gather more samples, I have more information. And this is, honestly, I think the most important metadata. You need all possible information about your modeling, log files or measurement, and it is metadata. How you have set your SDR devices, how you have set PRI, PRF, which type of modulation, what was length of pulse, what was distance of measurement, and so on and so on and so on. Everything must be recorded, because if you don't do it, I can bet with you that after 1 month you open raw data measurement and you don't know anything, under which condition you make measurement, and then you can just delete the data and go again, because it is not possible get this information from this. So be careful about this. I know something about it, because during our start of measurement sometimes we forget something and we need to modulate again, because of course we also sometimes you forgot something to save. So all measured data must have subsequent valid interpretation. You need to know condition. And about measurement, there is one thing. You never know speed of rotation. Do you agree? Because you just came to site, start of measurement, and you don't know how quickly rotate it. Always make video recording, because from video record you can easily detect one rotation. From one rotation you get lot of information, speed, type of wind turbines you already know it, so you can put every information to your model And then measurement and your model results, you will make comparison and it will be almost same. And what is advantage? You know setting of model, and now I can change just angle, initial angle, rotation of speed, and even if I don't have measurement for this different setting, I know that is valid because the setting was already one time set and confirmed. And this is really important. So also what you need to record, equipment. So in our case it was some antennas, okay, they are passive, so it was about amplifier. What was amplification of signal? Also, what was some noise number setting? What was everything? Record everything. Maybe it is looks that is annoying and that you don't need it. Okay, you don't need it now, but you don't know if you don't need it after 1 month, and if you don't have it, you don't have it. So also type of equipment, serial number, status, configuration, because what could be configuration? Sampling rate, something like this. If you don't have good sampling rate, okay, how you want to interpret data? Records of pre-measurement analysis, sensor position, of course, XYZ coordinates, weather, also information about weather, because weather influence reflections. So please also make just information. Sunny day, wind speed approximately 5 up to 10 meters per second. There was snow fog, I don't know, it is just example. Just make small record. It takes you 1 minute, but save your time for later. Because imagine if we go for measurement, it will be snowing. Also, it will be completely different results, or with sunny day. And it could happen that you will then designing mitigation algorithms, and you will be back on your data after 2 years. You don't know nothing about this, where it was. So photography, video, everything. It is enough. We always make with mobile. It is enough. You don't need high quality. Just make all these records. Of course, time of records, video. So it is rotor tuning rate and orientation. Yes, it is clear. I forgot. It is true. Orientation, of course. You can derive angle because you know it. You need it to angle for your simulation. I almost forgot. And in case that there will be some small roads or something, all roads, traffic. It was a lot of traffic. Okay, there is influence of this measurement, specific measurement by traffic. No traffic, okay, perfect. It is better believe more in these results where is no traffic. So proper metadata make it possible to reproduce experiments by your simulator designed. So it very help you. You can also compare scenarios. Okay, we make measurement and 3 kilometers and 5 in same line of sight. What is differences? But if you don't have information that was in 3 and 5 kilometers, for you is just data without any meaning. Also, if you will later model a lot of data, you can use it like thousands and thousands scenarios. You can make some automation script that you will run it one time, and he will take like individual scenarios, always compute for each scenario one reflected signal and continue with another, and it could be thousands of them. And then you can use it for ML AI algorithms for training dataset. But first, of course, you need to have validate that model is correct. Of course, it is true. But yes, it is like this. So metadata, big importance, because people very often forget about this. And I understand, because you go, I remember that was rainy. Yes, now, after 4 days, 5 days, 2 weeks vacation? No, you don't remember. Especially if in one day you make, like example, 10, 15, 20 measurement. No, you don't remember. Even, okay, it will be 20 measurement, I will not remember even during night, same day, because it is hard. So be careful about this. And it does not take so much time, honestly. There is example of acquisition planning. The goal was to design a campaign that yields to maximally information data for model validation and algorithm testing. So, of course, first we developed model, but we was not sure that was precise. It was just our idea. So then we design measurement chain. We working on this parallelly, of course, and we design new antennas, and there is some typical scenario. So it is control PC, antennas, SDR is below. I will show you more picture later, so don't worry. Now somebody of you can complain, yeah, but it is antenna that is static. True, we don't use rotation. Why? We don't need, because it will be more complicated for us. So we make recording from 6 up to 18 seconds due to data rate limitation. Not in our hard drive, it was enough space, but problem is with SDR. If you have bandwidth 40 megahertz, there is some cache memory, and after some time this cache memory start overflowing, so we need to adjust. So back to your question, we just adjusting this 40 megahertz that was related to cache memory of our SDR, because if we will put 50, 60 megahertz, because we want also more, SDR can't handle it with this high data rate, and always after few seconds of record cause it problem, overflowing and shut down. So I remember now it was about this SDR cache memory. But it depends on your devices. If you have better devices or real radar, it will be something else, of course, but we make this measurement. So our measurement, radar antenna position, we make record of coordinates. Height, it was about 450 meters high. Transmission frequency was about 3 gigahertz. Same like we use it during tutorial 1. Radar antenna rotation time, we usually agree about 10 seconds, but for measurement it is not valid, of course, because it was like continuous pulse signal that we send it to wind turbines. And it looks like big one, but main lobe was really narrow. So even we could separate each wind turbine. If you can understand me, we focus only on 1 or 2 second one. We don't make record of both of this wind turbine together. And it was possible due to this really narrow main lobe of antenna. So we precisely know where we are aiming. The repetition period was about half millisecond, and RF pulse was not modulated, so we don't use any pulse compression. But it is just for validation of measurement. We don't use compression even in our simulator, so we don't use compression even in our measurement SDR. But we can set it compression that we want, but we don't use it because we don't need it. We just want to make comparison. Of course, if we will use compression, then we need to use compression on measurement side and in also in, how to say, in simulation side. And then again, we get valid comparison if it's valid or not. So there is position of wind turbines. I placed this data because later you can play with it and you can just shown on map. Tower height was 80 meters, rotor diameter 80 meters. So it was like testing measurement. There is example, because you know that our simulator handle with each blade like with tube that is slice it to individual element. But you can easily download model of wind turbine, and it is free. This is a GrabCAD. It is free software again. You don't need spend any money for this, and you can download. It is just example. When I put to database in GrabCAD, that is free because it is from like community, from users. I found it maybe 50-100 different type of models of blades, devolving turbines, towers, and so on and so on. So this you can use it for your FEM simulation if you want in CST Studio or something like this. I don't know, do you know CST Studio? Yes. I thinking because almost everybody uses it. Who do it microwave or something? Yeah, exactly. So you know it. So you can easily download these models and just directly import. And not only wind turbine, it is thousands. So if you need, there is a lot of antennas also, different types that are adjustable. All parameters are adjustable, so you can even make changes in this model. So I recommend to it, and it is also free, so why not?
This one also simulation software.
Yeah, it is simulation. It is simulation. So of course, it's not so good like CST, but CST prices. It is licensed. I know. We have it also, because my colleague from microwave group, they use it also. But this is, you can check it. It is not bad software, and it is easy. So in this software, of course, you can control wind speed, because it's like some rotation, orientation, reflectivity of surface elements, everything. But probably your colleague will tell you more information than me, because I am not FEM specialist. I don't working with this. It is microwave things. And now I will go to last 7 slides will be related how different parameter of wind turbines influence your reflected signal. It is outputs from our simulator. Just make it GIF to. You can see that this is analysis of wind turbine nacelle orientation with respect to radar. So it is mean how, if it's this blades, how is rotated to my radar. So you can see that there is high variability. Okay, 0. What do you mean? If you see just this line, what is it? The red line. Now, it is just reflection from tower. It is mean that your wind turbine is just directly in this way. Why? Because its rotation and distance is still same, so there is no Doppler shift. When is maximum? Okay, there was maximum. It is like this one. Maximum Doppler shift. So you can see that, and check this one. It is like rotation of wind with respect to your, and Y is not in 0. Wait. Now, Y is in 330 or in 150. Because azimuth was not in 0, but is one bit, it was in 30 degrees. So you can see now nice example of our simulator, of our output. It is spectrogram. There is Doppler shift. So you can see that if there is radar, and I go with blades like this, it is increasing Doppler shift. It is clear because it is more speed with respect to my radar. If it's this, it is zero Doppler shift and it is just tower, static object. And how you can recognize it is static? Zero Doppler shift. Zero Doppler shift is static reflection from environment something. And everywhere where is blue, it is like zero. There is no reflection. But in real measurement, there not will be anything blue. Why? Environment. Of course, it will be messy. And you can also see these three harmonic signals. I know it is later I will have this picture, but no animation, so we can just check it later. So it is three harmonic signal. But please don't expect that in a real measurement, where is influence environment, you will see so nice three harmonic signals. You need to have big imagination, but it is work. Results are almost same, but you need imagination. Where is it? Because of course this is simulation. There is no environment. Reflectivity is unit, but RCS is not unit. It will be changing, of course. But we. So I will check if I forget something. No, I think that not. Okay, it is what I already present, but not in GIF. So you can check that in this. Okay, in this case, okay, it is 0, 30. Okay, it is maximum. Now it is like this. You can see tower, and if I will go. It is 30, it is okay, 0, 30, 60, 90, 120, 150, 180. So it is mean what? That I am looking like this, rotating, and then I am in opposite. So it is same like if I will go around with radar position. I just rotating with wind turbine. But what is disadvantages? I will take one measurement for one angle. I will validate that is with good setting of my simulator. I confirm result that is very similar or same. And then rest I simulate from my chair in my office. I don't need to go to again to make measurement. And in second thing, the condition will be never same, so another measurement. But now I can simulate. Even I have step 30 degree. You need more detail? Okay, just put more detail. All these input parameters like number of blades, angle, rotation, and so on, we save it in just Excel file, and you just put values that you want, and our simulator just read values from Excel and simulate and save result. So it is very big automation. So you will put you could put hundreds of simulator in a row, just press it, run, and come after a few hours, and everything will be simulated, and you don't need to spend so much time. Check this, and this result are same. Do you agree? Why? Because it is like this, and if I will rotate 180 degree, it is like this. Of course, it is the same. What is difference is, it is rotating like this or like this. It is just different area. And check this point and this point. It is like mirroring only. It is like mirroring. But of course, if we use same inputs data and just change angle, it must be same, just rotation. So if you want save time, you need from 0 to 180, and you don't need this one. If you want this one, just make mirroring in MATLAB because it is just metric, so and it is done. Sorry? 5 slides, 10 minutes. Please, please, please. I will finish and then we will go for lecture 5. Please, please. It will be quick because almost everything I already say. So, this is Doppler spectral component are caused by radial velocity. We know it. Non-zero component are artifacts caused by Doppler shift. But there is no Doppler shift, so it is mean that we are exactly in the way where it's only tower. Tower not caused our problem because it is MTI filtration. There is maximum Doppler shift, so it is mean that your blades are just in exactly position and there is biggest movement, and this radial velocity components of the tip velocity is done by this formula. It is speed of tip, and this is this individual angles, and maximum Doppler shift is derived from rotation speed, and it is some minus Fd max to Fd max. So radial span of velocities and consequently Doppler shift is orientation dependent, but it is clear we already saw it from result. And okay, it is just results what we say, and there I will show you next simulation, and it is changing of rotation speed, how it looks. So my rotation speed is 1 RPM, 4, 7, 10, 13, 15. You can put any value. What is maximum speed of the blade tips? Meter per second, 4, 17, 50, up to 55, and so on. And I today add that was for PRI 1 millisecond and blade length only 40 meters. It is just for example. Of course, you can put any value. And this is bandwidth of Doppler spectrum that is expected from minus 350 to 50, and so on and so on and so on. So, what was result? Check. What is happened? If will be higher rotation speed, the amplitude will be higher and higher and higher and higher and higher, and then go outside my range. You check it, and it is this picture. So there is detail. There is one sine wave which continue. There is second wave, but looks continue there. Okay, second side. It is go there, sine wave, but this part you can't see. Aliasing. How I already told you, aliasing. It is reflected to second side, and you have problem. Houston, we have problem because there our mitigation algorithm don't expect this one because he expect free sine wave. But due to aliasing, we are in opposite side. And there you have details. So low rotation speed, almost not any Doppler. So with low rotation, you can behave like static object. Higher, 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 it is almost maximum, how you can see. And if I will make bigger rotation, aliasing, and it is bad for our mitigation algorithm.